car battery is a rechargeable cell in the starting, lighting, ignition variety of batteries. They are also in the lead-acid family of batteries. Lead-acid batteries are the oldest style of rechargeable batteries. The high power output of a car battery is necessary to supply a high current draw needed for the engine starter. A normal car battery provides about 12.6 volts and is divided into 6 separate cells, and each cell produces about 2.1 volts per cell. As the battery's state of charge decreases, the voltage produced also decreases. Battery power is created through a chemical reaction. Inside your battery there are positive and negative lead plates that are immersed in an electrolyte solution called battery acid. This solution is a combination of water and sulfuric acid. When the solution interacts with the lead plates, the chemical interaction creates voltage. This voltage is then released through the battery's positive terminal, red, and returned to the negative terminal, black. Voltage from the alternator maintains the battery's state of charge. This continuous cycle can produce electricity for years. When the battery is overcharged or jump-started, water in the electrolyte solution is transformed into hydrogen and oxygen. This can cause an explosion from the battery if a spark or another source of ignition is present. If at all possible, it's recommended a damp rag be placed over the dead battery vent caps to help reduce the amount of hydrogen in the air during jump-starting. The amount of hydrogen and oxygen also decreases the fluid level inside the battery and can expose the lead plates. Exposure to oxygen can damage these plates and reduces their ability to provide the chemical reaction needed. Be extremely careful when handling a car battery. Protective gloves and eye protection are recommended because battery acid is highly corrosive. Rubber aprons can also reduce exposure to caustic chemicals. When charging a battery, use caution. Always connect the charge leads while the charger is off, as this will prevent a spark from being created. A battery is most prone to an explosion after a battery charge. The most common way to recharge your battery is by a process called trickle charging. This is performed using an inexpensive trickle charger. Most repair shops have a more powerful and more expensive battery charger that is capable of charging at a higher rate. Step 1. Use appropriate personal protective gear, including hand, arm, face, and eye protection. Park the booster vehicle close to the one that needs to be jumped, but not so close that the vehicles are touching in any way. You'll want to use a good set of jumper cables with thick wire and clean clamps. As you're hooking up the jumper cables, make sure they don't dangle into either engine compartment where they could get caught on moving parts, such as the fan and belts. Turn off the ignition of both vehicles, set the parking brakes, and make sure they are either in park or neutral, depending on whether the vehicles have an automatic or manual transmission. Also, turn off all accessories like lights, radio, and, if the vehicles are in a safe area, the hazard flashers. Step 2. Just remember that most American cars have a negative ground, and some older and foreign vehicles use positive ground. Determine if the vehicles are negative or positive grounding. We'll use a vehicle with a negative ground. Begin the process by clamping one of the positive jumper cable ends, red, to the positive battery terminal, labeled with a plus on the battery, of the dead vehicle. Be sure the connection is strong with the clamp securely biting onto the battery terminal. Step 3. Connect the other end of the positive cable, red, to the positive battery terminal on the booster vehicle. Again, confirm that a plus is next to the battery terminal. If the terminals are corroded on either vehicle, you may have to scrape them with an abrasive, such as steel wool, to achieve a solid connection. Step 4. Connect the negative cable end, black, to the negative battery terminal on the booster car. It's marked with a minus sign. Finally, attach the other end of the negative cable to an unpainted metal surface on the engine of the dead car. Find an unpainted bolt or bracket that is as far from the dead battery as possible. This will provide a solid ground while further reducing the possibility of igniting any hydrogen gas. Step 5. Make a final check to confirm that the jumper cables are not near any moving engine parts, and start the booster car. Let it idle for several minutes, depending on the state of the dead battery. If the dead battery is new and was drained by the lights being left on an extended period of time, it'll probably start immediately. If it's an old battery, or it's sat for a long time, or more than a month, it will probably take a while to charge it sufficiently. Step 6. Start the dead vehicle and let the two vehicles idle for a few minutes. If the dead vehicle refuses to start, don't keep trying or you might damage the starter. If there is the possibility of additional problems like lack of fuel, don't continue trying to start the dead vehicle until the other problem or problems are solved. Step 7. Once the dead vehicle is started and running smoothly, disconnect the jumper cables in the reverse order that they were connected. As you disconnect them, be careful not to let the dangling cables fall into the engine compartments or touch each other. Step 8. Drive the revived car to somewhere safe and secure before shutting off the engine. Depending on the battery's condition, it might need to be jumped the next time it's started. To properly charge the battery, attach it to a certified battery charger and leave it connected for at least 12 hours. You can also take it to an automotive repair shop for complete charging. Driving the car for an extended period can also charge the battery, but this should be done only if the other two options aren't available. A vehicle's alternator is primarily designed to maintain a battery, not to charge it from a complete drain. Maintaining a car's battery is a necessary step in any vehicle's preventative maintenance and should be checked regularly. Clean battery and terminals. There are deposits that can form on the battery terminals. These deposits are corrosive byproducts of a normal battery charge and discharge function. While wearing protective gloves and clothing, use a garden hose to rinse the battery completely, including the surrounding area. This will dilute the acid to a non-corrosive state. You can also sprinkle baking soda to help neutralize the battery acid. Use a wire brush on the battery terminals to clean thoroughly and reassemble. Recheck charging system as needed. Battery storage. Charge your battery to full capacity. Store in a cool place, but not where it will be below 0 degrees centigrade or 32 degrees Fahrenheit. Check the battery every 2 months and recharge if needed. Remove all electrical connectors from the battery. While we're on the subject of battery storage, what about storing batteries on concrete? The main issue with storing on concrete is that if a battery leaks, the concrete will be damaged. Long ago, when battery cases were made out of natural rubber, this was true. Now, however, battery cases are made of a polypropylene or other modern materials that allow batteries to be stored anywhere. A battery's rate of discharge is affected by its construction, its age, and the ambient temperature. Replace battery cables. If excessive corrosion on battery cables are observed, they should be replaced. Corrosion can cause high resistance, resulting in a starter operation failure. Avoid using aftermarket cables as they may not be manufactured to proper specifications, resulting in poor battery performance. Recycling old batteries. An old car battery is completely recyclable. Contact your local recycling station, auto parts store, or repair garage. Do not discard an old battery in a landfill or other unauthorized area. Prolonged overcharging or charging at excessively high voltage causes some of the water in the electrolyte to be broken up into hydrogen and oxygen gases, which escape from the cells. If the electrolyte liquid level drops too low, the plates are exposed to air, lose capacity, and are damaged. The cells can be topped up with distilled or deionized water just above the visible plates. The sulfuric acid in the battery normally does not require replacement since it's not consumed even on overcharging. Impurities in the water will reduce the life and performance of the battery. Manufacturers usually recommend use of demineralized or distilled water, since even potable tap water can contain high levels of minerals. Corrosion at the battery terminals can prevent a car from starting. To prevent corrosion, during regular battery service, the terminals may be cleaned with a wire brush and corrosion products washed away with water. When the battery terminals are reassembled, they're coated with Vaseline petroleum jelly, but don't use grease. Vaseline will help reduce the rate of corrosion accumulation. Exploding batteries. Any lead-acid battery system, when overcharged, will produce hydrogen gas. If the rate of overcharge is small, the vents of each cell allow the dissipation of the gas. However, on severe overcharge, or if ventilation is inadequate, a flammable concentration of hydrogen may remain in the cell or in the battery enclosure. Any spark can cause an explosion, which will damage the battery and its surroundings, and which will disperse acid into the surroundings. Car batteries should always be handled with proper protective equipment, such as goggles, overalls, and gloves. We're sure you've seen many different methods of jump-starting batteries, but if you follow proper safety procedures, it's difficult to have an accident or battery explosion. Thank you.